Hey guys, welcome back to another lesson. We are going to be talking about exponential functions today. It is the first topic that we'll be talking about in Chapter 8. Just as a heads up, Chapter 8 is a more difficult chapter. That's why I waited until the end. Obviously not my best choice since we are now doing everything via distance learning. But then again, who could have foreseen that? Anyway, be sure to keep in contact with Emily and I during this time. It is a really difficult chapter and you're probably going to have a lot of questions, but we're going to try to keep it as simple as possible, as we've been calling it here at Tower View, down to the bones. So here we go. Let's get started on the lesson. Today we are going to discover how exponential functions can be used to model social, scientific, or personal finance situations. Chapter 8 might be hard, but it's also one of the most applicable parts of Algebra 2 Semester 2. And actually, funny enough, it's very applicable to what we are going through right now. You know, this pandemic and how the infection rates are growing exponentially. Sorry to add a little bit of scare factor to exponential functions, but here's a prime example of how it applies to everyday life. So we have population growth, radioactive decay, and loan interest rates are a few examples of naturally occurring exponential relationships. So we're going to learn how to model these situations using an exponential function to predict behavior, calculate half-life, or plan your budget. So we have an exponential function with base b is defined by f of x is equal to ab to the x, where a is not equal to 0, b is greater than 1, b is greater than 0, b is not equal to 1, and x is any real number. The base b is constant, and the exponent x is a variable. Take note of that line right there. The base is b, and the exponent is x. Over the course of your time in math, you've seen a lot of equations like y equals mx plus b, or y equals ax squared plus bx plus c. In these, x is not the exponent, it's the base. The exponent here is 2 or 1. We are flipping that kind of thought now, and x is going to be the exponent with a constant base. All right, so let's go through this. Okay, note how it skips right to number 5. You can cross up 1, 2, 3, and 4 because we will be doing a lesson on graphing exponentials in the next section that you have to do. I'm going to pair graphing logarithms and exponentials there. So number 5, 6, and 7, it says without graphing, say if the graph shows graph grows or decays. For this, what we have to do is we have to look at it in comparison to 1. So if it is greater than 1, we're looking at b. If b is greater than 1, then it's a growth. If b is less than 1, it's a decay. Notice how I don't have an equal to option. On the last slide, we did see that b is not equal to 1. So we're looking at either greater than or less than 1. Well, let's start. 1.6. Since we are almost at the end of our high school career, we should know that 1.6 is greater than 1, which means it is a growth. All right, 6/5. So you could put this into decimal form, or you could look at it as 6 over 5 in comparison to 5 over 5. 5 divided by 5 is 1. And if we're looking in comparison to 1, then we're looking in comparison to 5 over 5. Well, so we have 6/5 in comparison to 5/5. Well, 6/5 is greater than 5/5. So that is also a growth. The other option here, if you don't feel comfortable working with fractions and figuring out what's 1 and whether or not it's greater than or not, is you can take 6 divided by 5 on the calculator, and you will get out 6/5 is equal to 1.2, which is also still greater than 1. So it's still growth. It's your choice how you want to go about that problem. think about what is easiest for you. And our last one, we have 0.8. Well, 0.8 is less than 1, so that would be a decay. And that's all we're doing for those 3 problems. Probably shouldn't have done all 3 of them for you, but it's too late now. All right? Flipping to number 11, because you do not have to do 8, 9, or 10. If we were in person, I would be making you do them, but they are extremely complicated, and it's just going to be too difficult to do over an email or via Google Hangout or something like that. So we have a new car that sells for $18,000, depreciates 25% each year. Write a function that models the value of the car. Find the value of the car after 4 years. So we have to flip back to our first page, and we have to look at y is equal to abx. To put it in that form. Okay, so a, in this case, let me flip back to this page, is going to be our starting value or the initial value of the car. I'm just going to put initial value because you guys are going to want to write this down so that you kind of know what a, b, and x stand for in even a different problem. All right, b is going to be your growth or decay value. And I'll give you an equation for how to figure that out in just a minute. All right, and then finally, we have x. X in this case is going to be our number of years. So we're going to go through and we are going to just fill that out now. So we have y is equal to a, which is our initial value. Well, our initial value was that it's sold for $18,000. And b, we don't know what our b is. Our b is not 25 or 0.25 or whatever you might initially react to think it is. I'm going to extend the page here. B has a special equation. B is equal to 1 minus r, where r is equal to our depreciation. All right, if it said, for example, on number 12, it says it increases at a rate of 12.5% each year, you could also have b is equal to 1 plus r, and that's where r is our increase value. This goes back to the last slide where we were figuring out if r is greater than 1 or less than 1. If it was less than 1, it was a decay. If it was greater than 1, it was a growth. Well, going back here, if we are subtracting from 1, it's going to be less than 1, which means it's a decay. If we're adding to 1, it's going to be greater than 1, which makes it our growth. Let me adjust this just a little bit so you guys can see the full screen. There we go. So now we know that it's a depreciation because it says it depreciates at 25% each year. So 25% as a decimal, we divide by 100, which in this case will move the decimal place to the right 2. So that'll give us is equal to 0.25. So that's our r value. Not our b value, our r value. So then to get b, we go back and we take b is equal to 1 minus r, which is 0.25, which is equal to 0.75. That is our b. So we go back and we plug that in. So we get 0.75, and then we just put to the x. Okay, that was a little messy, Probably should have organized that a little bit better, but there's our answer for the function that models the value of the car. Okay, you guys are going to finish this problem up. The next part says find the value of the car after 4 years. All you have to do is take 4 and plug it in for x. Okay, make sure you are taking 0.75 to the 4th and then timesing it by 18,000. Do not take 18,000 times 0.75 and then take that to the 4th. They are very different answers. All right, so you guys are going to do number 12 on your own. If you have any questions, reach out to us, let us know. And then the last thing we are going to do is find the percent increase or decrease. So this is going to be going back to that R value practice. All right, so let's look at it. We know that, I'm going to write it up here, B is equal to 1 minus R, or B is equal to 1 plus R. So if we know B is equal to 1.63 here, we can fill that in. So we go 1.63 is equal to 1. And actually, I believe in this case, we only want to use the plus R form. Because if your B is less than 1, you're going to get a negative number anyway, which is going to give you whether it's an increase or decrease. So we're going to do 1 plus R. So doing a little algebra, we subtract 1, we get R is equal to 0.63. And we have to convert that to a percent, which we've been doing for a while now. We take it times 100. So we get R is equal to 63% increase. It's important that you clarify whether it's an increase or a decrease when you're doing your answers. All right. I'm going to give you guys a little bit of help. 1/4 is 0.25. 17 over 10 is 1.7. You guys probably didn't need help on those, but I'm going to provide it anyway. So I'm going to do number 14 with you, and then you guys will have to do 15 and 16 on your own. So to finish this assignment, you're just going to have to do the rest of 11, all of 12, and then 15 and 16. Not terrible. You can manage it. So let's look at this one. Our B is 0.65. So we have 0.65 is equal to 1 plus R. So we subtract 1, we get R is equal to a negative 0.35, which then we take that times 100. So we get R is equal to negative 35%, or in other words, R is equal to 35% decrease. Okay, pause the video, write down any questions you have. Make sure you send them to me or to Emily so we can get through this. Only 2 more assignments after this one, and then a test, and then we are done with the class. So we're getting there. Stay strong, and we hope to see you guys in person soon.